Hello, good morning, colleagues. Today we are going to solve exercise 3.12 from the book Fundamentals of Electrical Circuits by Sadiku. In this exercise we are asked to determine the voltage V sub 0. Here it is marked in the circuit in the figure. Well, first of all, what I always advise that we should do is a visual inspection to determine the possible current paths. Notice that here there is a voltage source of 30 volts and here there is a resistor. Therefore, I assume that a current is going to come from this side due to the polarity of the source, and I give the names of the currents right now after I mark them. Well, this one, let's note that we need to determine the voltage as 0 and give us the polarity of the resistor. Therefore I assume that the other current comes in this direction, since it is polarized from above, and the direction in this section would be missing the resistance, since this is an independent current source that goes up to this node and from there a part that comes to this side and the other part, then towards this other, and in the end it goes down and up. So I'm going to call it A and 1, I'm going to call it A and 2, and I'm going to call this 1 and 3, well, this. Node that is here is the same 0 voltage with respect to ground. It is the same node that is here. This is the same as this resistance because they are in parallel at this point, so I am going to call it V1 and I am going to do the respective node analysis. Then I am going to stop at node B. It is going to go this and this. I'm going to look at the currents that enter the same, the currents that leave. So the currents that enter at this point are the current I1 and the current I2 I1 plus. I2 is going to be equal to the current that comes out, which would be the I sub the 30 volts. Subtract 1 because the direction of the current does not. That is, it means that 30 volts we are assuming is going to be greater than the voltage V1, so it would be 30 minus V1 over 10 ohms. Plus all this about the current and a certain voltage over the resistance plus the current. Then it would be the, as I am noting it to the left, it would be 0 minus V1 over AUFO. No. That would be the current, and 2 the current 1 plus positive is going to be equal to the current YX times the current YX, the one that comes here. This would be V1 about 2 men. Okay, now what we have to do is apply algebra would be 30 divided by 10. We are the unit. I put it right now, minus V1 over 10 plus 0 weight over 1 minus V1 over 1 equals AP1 over 2. I'm going to pass this whole expression to the other side of the same over there, and it's going to stay. I'm going to put it here. I'm going to put it here. I would have V1 out of 2 plus V1 out of 10. It gives me more V1 over 1. This one is here and this one has negative polarity. I move it to the other side with positive polarity. This one that has negative polarity. The other side with positive polarity, put V1 first, and at the end I have 0 over a negative 1 in it. Remains equal to 30 over 10. Well, then if I add all the V1s, that is, 1/2 plus 1 over 10 plus 1 over 1, this is going to look like 8/5 of V1 minus E over 1 would be sub 0 equals 333 E. I'm going to multiply all this by 5 to eliminate this denominator. Here I have 8 volts 1 minus 5 sub 0 equal to 15. I'm going to delete all this. I don't need it anymore at the moment. And that would be our first equation. Now I am going to do the same analysis but applied to node 0. Well, I'll stop here at this node and I'll look at the currents that enter as well as the currents that leave. As we can see at this point there are 4 in X. We have Kirchhoff's law tells me that the currents entering a node is equal to those leaving times the total sum at the node is equal to 0. That's when we equal it to 0. Here in this node 4x comes in and the 2 currents come out. The Y2 more and 3 come out. So, and XA which is equal to good and X is equal to B1 over 2 in the stream and X passing through here would be 4 times B1 over 2. This is X. Solving in terms of voltage and resistance equal to 42. The 42 is the one that comes here and it would be 0 minus V1 over 1. 0 minus V1 over 1 plus the current and 3 that the current is the one that comes from here reaches the ground. In this node let's remember that the tension is 0. It says that it is 0 over 5. That's the current. This is the current N2. And this is stream. Well, then by applying I am going to obtain that here I would have 2 V1 equal to 0 minus V1 divided in oneself. The same variable plus 0 over 5. I'm going to pass this on. Well, I'm going to leave it in positive terms and I'm going to get over all this now. It doesn't matter if I don't pass it, the result has to be the same. So there will be 2 V1 left plus V1 minus 3 0 minus times 0 over 5 because it's going to be equal to 0. Well, now what we have to do is apply algebra. Then this would look like V1e minus 1 minus 1/5 which would be minus 6/5 of. Should this be equal to 0? So, if I multiply this by for 5 also to eliminate this denominator we will have E15. V1 minus 60 equals 0. This is our equation 2 ready. We put this equation in the calculator or use MATLAB. If I wanted to use it wrong, I would have to use the equations here. I'm going to delete this. Well, I'm going to delete all this and I get that the first one would be 8 minus 5 and 15 to 6. Here it would be 0 key 8 minus 5. semicolon, and the other would be 15 minus 6. 15 minus ready keys, and V is what is in it, just as it would be 15 and 0. 15 semicolons. Well, I'm going to comment out this line of code first so you can see that the matrices fit us well for the program to 8 minus 5 15 minus 6 8 minus 5 15 minus 6 and 15 and 0 for the matrix B. 15 and 0. So I solved that and I get that this would be V1 and this would be V sub 0. So sub 0 gives me minus 8.33 volts V 1 and V0 V 1 gives me minus 3.33 minus 3.33 volts, and that 0 minus 8.33 volts. This would be the result of 0. Well, the exercise ends here. See you in the next one.